Hello and welcome to the lecture. So, in the previous lecture, we have studied about the Orgel diagrams and we have already studied the Orgel diagram for D1 and D9 D1 and D9 cases for octahedral complexes. Now, in this lecture, we will first study the D1 and D9 electronic configuration when we have tetrahedral complexes. So, in this lecture, we will study the Orgel diagrams for the D1. First of all, let us study about the D1 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 tetrahedral case. D1 tetrahedral case. Now we know that in case of the D1, the term that we have already generated when we were studying in the D1 in case of octahedral complex, the term it came out to be equal to dt. It came out to be equal to dt. D2. Now we know that the D term the D term it splits like this. So we will use the Orgel diagram so that we can represent the D2 splitting. D2 under the ligand field environment, under the ligand field. So here in this axis, that is x-axis, we have ligand field strength. We have ligand field strength. And here on the y-axis we have, this is our D2 term. Now what will happen here? Since we know that in the tetrahedral case, D2 it splits into E and T2 term. It splits into E and T2 term. Why there is not EG and T2G? Because we use G and ungerard when we have center of symmetry. But in case of tetrahedral, we don't have any center of symmetry, so that is why these are omitted when we use tetrahedral case. Now suppose this is our barycenter. This is our barycenter. Now under the ligand field environment, this D2 term it splits like this. It splits into this T2, and here we have what we have spin. The spin multiplicity it is 2. Similarly here this will be E, this will be E2. This will be our E2. So under the ligand field strength, the D2 term in the case of tetrahedral it splits into lower energy state E2 and the higher energy state with the configure with E2. Now what will happen? It means that if we have electron in case of tetrahedral, it will undergo transition from E2 to T2. So here we will represent the transition like this. So this is the transition, or the electron it will undergo transition from E2. This will undergo transition from E2 to T2. So this is the Orgel diagram for the D1 case. When we have the geometry of the complex, it will be tetrahedral. Now we will first of all, let's understand the case for D9, and let us understand the case for D9 when we have tetrahedral complex. So the D9 case for octahedral that we have already studied in the previous lecture. Now when we talk of D9 configuration in case of tetrahedral case, we know that there will be splitting and the electrons they will be filled like this. So this is our E, and here this will be our T2. This will be our T2 case. Now how many electrons we had to fill? We had to fill 9 electrons. So we will fill like this. We have 1, 2, 3, 4, 5, 6, 7, 8 and 9. We have 9. Now we have already studied that this will be our hole. This will be our hole. So it seems that there will be hole transition. There will be hole transition. So when there will be hole transition, what will happen? The terms they will replace when we use Orgel diagram. So we have already studied that in case of tetrahedral complex, in case of D9 having tetrahedral complex, the term that will come out to be equal to, it will be equal to D2. So that we have already studied how we can explain or how we can generate the D2 configuration by using the concept of angular momentum. So that we have already studied in the previous